As I promised, I'm going to do a series of videos on logarithm. So today we're going to start with the introduction to logarithm. So to begin with, I'm going to just write the very core rule of logs, and then explain a little thing around it, and maybe we do an exercise together. So the log. Now I am very specific in the way I write my logs. So log would have a subject, or some people call it content. So log is actually working on its subject A, and the base is B. And let's say that has an answer n. Now that is equivalent to a exponential relationship, and that exponential relationship is that b, which is the base, to the power of n will be equal to subject A. So these two are totally equivalent to one another. Logs, what I was saying about writing logs in a specific way is that the subject generally needs to be of a larger font, and lifted and placed in very similar place where I'm putting it. And base needs to be written with a smaller font, and very close to the logs. The reason writing it like this is quite important is that when you're solving questions and you're going through the process of working through the rules of log, having it written like this make things a lot more clear, and stands out as what the next step would be. So try and practice writing it like this and also reading it like this. So it will be log of A to the base B, log of A to the base B. So log is just like other mathematical functions, like for example sine. Sine by itself doesn't really have functionality that we can work with. Sine only becomes of some value and usefulness when it has an angle. So we have sine. So what I'm saying is sine isn't just three letters, sin. It's a function that requires a content or a subject to go with it. The base of log, or for example, a root. Can have a root 64. Now, at the moment, the root is, because we haven't written any index here, this is a square root. So just like this function, which has a content to go with it, logs will have a content, sine will have a content, that has a subject to go with it. So the root is working on this subject. It would be silly to just write the root and nothing to work on it. And so at the moment, the importance of base here, the importance of base is telling us how the log is going to proceed working on its subject. So for example, here at the moment, although it's not written, but the square root actually has an index of 2. So when the index is 2, so the base of this root is 2, then the answer would be 8. But if that was if that base was different, so for example, if it was cube root, then the answer would be 4. So base on the basis of what the index here is, the answer of this function that's working on 64 as its subject will change. Now, two logs you will come across on your calculator. One is just log. Log on your calculator does have a base 10, but it's not written. So, log of 100. So if it's no base there, if there is no base written there, we assume that the log is working on the base of 10. And there is another log, and that log is to the base e. And if that's to the base e, we don't actually write this as a log. That's generally just log natural of 100. and you will see ln on your calculator. So the relation, if you go back to the log here, so we said that the log will have a subject. So this is a log of a using base b, and if the answer is n, this is totally equivalent to, mathematically, totally equivalent to b to the power of n equals a. Now I quite like this cycle to pay attention. So b to the base n equals a. So b to the base n, so I like that little cycle there. B to the base n equals a. So if you can see that cycle, then you know that you're working it correctly. Yeah. So if for example we're doing 100 to the base 10, then if you're looking to find the answer of that, the answer should be such that when you do 10 to that power, it should be equal to 100. And so therefore we now know that the answer here is 2, because 10 squared is equal to 100. Yeah, so the answer is 2. So let's just practice this a little bit. I have already placed an example here. Let's make it a little bit larger. So we're just going to practice this cycle here. So we have a log of are you all locked to me, guys? Okay, all right. Here we have a log of 8 to the base 2, and I'm going to try and read it in the way that you should also read it. Log of 8 to the base 2, and the answer would be 3, because 2 to the power of 3 would be equal to 8. Yeah. That's 10 million, log of 10 million to the base 10. So the answer would be 7, because 10 to the power of 7 is actually 10 million. And 3 to the power of 6 is 729. Yeah. And 4 to the power of minus 1 would be 0.25. 0.25 is a quarter. So as you know, a quarter is actually equal to 4 to the power of minus 1. Yeah, and this is simple because a to the power of 10 gives you a to the power of 10. So a to the power of 10 is equal to a to the power of 10. Yeah. And here the answer would be squared, because 5 squared is equal to 25. That would be 1, because 12 to the power of 1 is actually equal to 12. This one would be a half, because 10 to the power of a half is the same as square root of 10. Yeah, this is a little bit odd. So if you think of 0.25, as a quarter, then quarter has to be sent to a power that will give you 16. So that will be a power minus 2, because it reciprocates the quarter. So in fact what we're saying is quarter to the power of minus 2 is in fact equal to 16. Yeah. So that 2, that negative there. So if that negative there wasn't there, and we just had quarter squared, so if we just had quarter squared, you get 1 over 16. But because there is a negative there, that will reciprocate the answer, which means the 1 over 16 actually becomes 60. Now that one obeys the same rule as up here, because if I put 2 here, then as you know, 2/3 to the power of 2 will give you 4 over 9. Yeah. So 2/3 squared will actually give you 4 over 9. But the answer isn't 4 over 9. The answer is 9 over 4. So that tells me that that power needs to be a negative power. So it will reciprocate the answer to give you 9 over 4. At the moment, the only thing that we discussed in this video was an introduction to log. So going back to what we said, so you have log and ln described. So log by itself is really a base of 10. So if you didn't see a base there, you can assume that that is a log to the base 10. And if you see a ln, it means that the base has been a natural number e. You've seen the natural number on your calculator. We'll talk about natural number some more later on. But if you see a ln, then the base is that specific natural number, is 2.7 something. Yeah. So in our future, so don't forget this cycle. I quite like this cycle, and it makes sense for you to also keep visualizing that cycle. So it's the base to that power that gives you the answer. In future videos, I'm going to do the rest of the rules of logs, and we also would do examples on those as well. For the time being, I'll leave you with these examples. So 2 to the power of 3 makes 8, 10 to the power of 7 makes 10 million, 3 to the power of 6 makes 729, 4 to the power of minus 1 makes a quarter, and so on and so forth. Well, we'll leave it at this point, and I'll see you soon in my next video.